Okay, so what we're going to try to do now is check the grid potentials and maybe some other voltages on the output tube, since we've discovered that there's appears to be anyway a problem in the audio section of the radio. We've injected a signal essentially right into the grids of this tube and not got the response at all that we want. I'm just quickly scanning through here, trying to spot something. Yeah. Fortunately, the pin numbers are written right on here. I think the way this works is this is one tube, this is one tube, this is one tube. Yes, that's definitely how this works. So it's pin 7 and pin 2 of 3 ECC83s. Now, where are these in the circuit diagram? They're up a little higher in the radio. Up in this area. Okay, the two ECC83s that could be easily implicated are these two back here. It's just a little awkward to get in there. Tilt this radio up. Well, maybe I can prop it here. Let me see. I can prop this up to get a little better angle on it. There's a plastic grill here. I don't want to put the weight of the radio on the plastic grill. Yeah. Okay. A little wobbly, but it's not ready to fall. That's so I can see up in here a little better. There we go. Now it's pins 2 and 7, I believe. Yes, 2 and 7. Those are the grid pins. Okay, it's kind of barely in there. Okay, so let's just see the voltage. So what we're expecting is essentially 0 or a slight negative voltage. Now, let's see if we can spot. And the radio's not on right now, so there's pin 1, there's 2, 3, 4, 5, 6, and 7. And up here, there's pin 1 there, 2, and 3, 4, 5, 6, 7 would be this guy here, I think. Okay, so they're not too hard to access with the meter. So all these capacitors, they look, here's one. There's a piece missing right out of this capacitor. It's actually broken and fallen right out. These all have some kind of compound coming out of them. Yeah, likely targets of failure for sure. All kinds of them in there. Yikes. Okay, so let's fire up the radio. Everything should be okay. There she goes. Where she stops, nobody knows. Should be warmed up. Now let me show you another weird thing I spotted in here. I meant to show this before I put the meter in here, but I can still get a... I found this laying around in there. What's that look like? Well, it looks like bristles out of a broom. That's what it looks like to me. So we found a chain, a broom. What else are we going to find in this radio? Still no gold bars. Really disappointed about that. Okay, so let's do some testing now. Pin 1. Pin 2. Let me get my hand in front of it here. Okay, so there's the grid. Slight negative voltage. Perfect. Pin 2 around to pin number 7. 1, 2, 3, 4, 5, 6. Wow, okay. I think that might be 7 there. Oh. Slight negative voltage. Perfect. Now try the next one. Pin number 2. Very slight negative voltage. And pin number 7. Ooh, maybe that's not 7. How many pins are on here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 pins. So we'll count back 9, 8, 7 puts it in here. And there you see 0 on it. Okay, that didn't help one bit. Let's try just for fun, the grids on the last, and the last one is way up in here. For me, it's way up in there, up in there. So get a ground here. Oops. Okay. 1, here's pin 2. Uh-oh, that didn't look right. Pin 1, pin 2. Uh-oh, something not good there. I'll check that in a moment. Pin 2. Oh, maybe that wasn't pin 2. Oh yeah, that's pin 2, all right. 1, 2, 3, 4, 5, 6. This is 7. Wow, what's going on there? They're both reading very high voltages here. Let's see, how high is it, Jim? 22 positive. And the other one is 8, 7, 71 positive. Am I doing the right thing here? So that's pin 1, 2, 3, 4, 5, 6, 7, 8, and 9. Oops. Pin 7. Got to be that guy right there. 72 volts. Pin number 2 is right here. 22. Okay, am I doing the right thing here? ECC 83. Yes. Well, it looks like 2 defective capacitors there. Let's look on the other side of the capacitor. Ground. And now that's the capacitor. Okay, so on this side, you see 25 volts, 26, and over here on this side we see 23. So it's as if this thing is just leaking like crazy. And we come over here, and that's the capacitor. Okay, so on the grid side, whoa, slipped. 73 volts, and on the other side of it, 84. So wow, doesn't that sound like 2 leaky capacitors there? Yes, you'd be surprised if all those capacitors are leaking. So it looks like we've got to open those 2 capacitors and check them out. Okay, so we're going to free up one end of this capacitor, get it off the connection there, and then test the capacitor out of circuit and see what we get. Get this wire out of the way. Steady up the radio a little better. Yeah, that's a little better. I was experimenting with all kinds of camera angles and stuff off camera just before I started recording this, using some magnifiers and other stuff, and you know what, I just couldn't get the right combination here to my satisfaction to give you a really good view. So obviously I have some camera work to do here. This may not be easy to get out. My soldering iron's not turned up high. Phooey. I just have to give it another minute to warm up more. It's not very hot yet. Okay, it'll be hot enough now. I don't think there's anything easy about this. These wires look like they were wrapped around the terminals, of course, when it was made. So another alternative, just cut this guy right out. You know what? Why don't we do that? I'm going to cut him right out. I can replace it. Cut it out. We'll leave. We'll cut one side. Make sure the radio's off. Yes. So there it is. Let's read the resistance across that guy and see if he's not a terribly sick puppy. Okay. One lead on one side. Okay. And the other on the other. Look at that. This capacitor is a piece of junk. That's what that tells me. What do you see? I can't see the meter. You can see it. I can't. What's it doing here? $300K. That's no good. Okay, so I think if we change those two capacitors, we will correct the positive grid voltage, and voila, the radio may start working. So that's what we're going to do next time.